the Geostationary Operational Environmental Satellite System, operated by the United States National Environmental Satellite, Data, and Information Service, supports weather forecasting, severe storm tracking, and meteorology research. Spacecraft and ground-based elements of the system work together to provide a continuous stream of environmental data. The National Weather Service uses the GEOS system for its United States weather monitoring and forecasting operations, and scientific researchers use the data to better understand land, atmosphere, ocean, and climate interactions. The GEOS system uses geosynchronous satellites since the launch of SMS-1 in 1974 have been a basic element of U.S. weather monitoring and forecasting. GEOS data can be accessed using the Speeders software. Satellites. 4 GEOS satellites are currently available for operational use. GEOS 12 is designated GEOS South, currently located at 60° W. GEOS 13 is designated GEOS East, currently located at 75° W. It was placed in orbit on May 24, 2006, underwent post-launch testing through early 2007, then replaced GEOS 12 as GEOS East. GEOS 14 is currently in storage at 90° W. It was temporarily designated GEOS East due to technical difficulties with GEOS 13, and moved toward the GEOS East location, but after resolution of the GEOS 13 anomaly, GEOS 14 returned to storage. It was launched on June 27, 2009, underwent post-launch testing until December 2009 and then was placed in on-orbit storage at 105° W. GEOS 15 was launched on March 4, 2010 and is designated GEOS West, currently located at 135° W over the Pacific Ocean. Several GEOS satellites are still in orbit, either inactive or repurposed. GEOS 3 is no longer used for weather operations, but is a critical part of the communication links between the United States and Amundsen Euroscott South Pole Station. Geostationary satellites cannot ordinarily be seen at all from the poles, but they require station-keeping fuel to keep them stationary over the equator. When station-keeping fuel runs out, solar and lunar perturbations increase the satellite's inclination so that its ground track begins to describe banana lemma. This usually ends the satellite's primary mission. But when the inclination is high enough, the satellite may begin to rise above the polar horizons at the extremes of the figure 8, as is the case for GEOS 3. A 9-meter dish was constructed at the station, and communication with the satellite is currently possible for about 5 hours per day. Data rates are around 2.048 Mbps bidirectional under optimum conditions. GEOS 8 is in a parking orbit, currently drifting about 4° W daily. It was decommissioned on April 1, 2003, and deactivated on May 5, 2004, after the failure of its propulsion system. Weather data was lost for 13 days from GEOS 12 on December 4, 2007 when it performed a standard station-keeping maneuver. GEOS 11 initially took full disk images to cover the lost data until a contingency plan could be implemented. On December 5, 2007, GEOS 10 was moved from South America operations to temporarily replace GEOS 12 as the GEOS East operational satellite. On December 9, communication with GEOS 10 was also temporarily lost, but communication was resumed via a backup antenna. GEOS 12 was successfully reactivated and moved back to normal operation following a thrust maneuver on December 17. The trouble was traced to a leaking thruster valve, which pushed the satellite incorrectly. Emergency procedures were executed to cut off the valve, and a redundant thruster was activated to restore the location of the satellite. GEOS 10 was decommissioned on December 2, 2009 and was boosted to a graveyard orbit. It no longer had the fuel for required maneuvers to keep it on station. It joins GEOS 8 and 9 which are already in graveyard orbits. With the cessation of GEOS 10's duties, GEOS 13 has replaced GEOS 12 as GEOS East. GEOS 12 was then moved to 60° W and resume South American duties for GEOS 10. GOES-11 had a partial failure December 6, 2011, was decommissioned on December 16, 2011 and was boosted into a graveyard orbit. GOES-15 was moved to 135° W as GOES West. GOES-13 was previously out of service, from May 22 to June 9, 2013, due to technical difficulties following a micrometeoroid collision. It is designated GOES East, and is currently located at 75° W. It provides most of the U.S. weather information. Purpose: designed to operate in geostationary orbit 35,790 km above the Earth, the advanced GOES-EUROM spacecraft continuously view the continental United States, the Pacific and Atlantic Oceans, Central, South America and Southern Canada. The three-axis, body-stabilized spacecraft design enables the sensors to stare at the Earth and thus more frequently image clouds, monitor Earth's surface temperature and water vapor fields, and sound the atmosphere for its vertical thermal and vapor structures. Thus the evolution of atmospheric phenomena can be followed, ensuring real-time coverage of meteorological events such as severe local storms and tropical cyclones that directly affect public safety, protection of property, and ultimately, economic health and development. The importance of this capability has been exemplified during Hurricanes Hugo and Andrew. The GOES-EUROM series of spacecraft are the principal observational platforms for covering such dynamic weather events and the near-Earth space environment for the 1990s and into the 21st century. These advanced spacecraft enhance the capability of the GOES system to continuously observe and measure meteorological phenomena in real time, providing the meteorological community and atmospheric scientists greatly improved observational and measurement data of the Western Hemisphere. In addition to short-term weather forecasting and space environmental monitoring, these enhanced operational services also improve support for atmospheric science research, numerical weather prediction models, and environmental sensor design and development. Data is received via the NOAA Command and Data Acquisition Ground Station at Wallops Island, Virginia. The GOES satellites are controlled from the Satellite Operations Control Center located in Suitland, Maryland. During significant weather or other events, the normal schedules can be altered to provide coverage requested by the National Weather Service and other agencies. GOES spacecraft also provide a platform for the Solar X-ray Imager, and space environment monitoring instruments. The SEM measures in situ the effect of the Sun on the near-Earth solar terrestrial electromagnetic environment, providing real-time data to the Space Environment Services Center. The SESC, as the nationally Euro-1 registered trademark SA Euro-OS Space Weather Euro Service, receives, monitors, and interprets a wide variety of solar terrestrial data, and issues reports, alerts and forecasts for special events such as solar flares or geomagnetic storms. This information is important to the operation of military and civilian radio wave and satellite communication and navigation systems, as well as electric power networks, and to the mission of geophysical explorers, shuttle and space station astronauts, high-altitude aviators, and scientific researchers. The SXI provides high-cadence monitoring of large-scale solar structures to support SESC's monitoring mission. However, the SXI unit on GOES-12 has been rendered inoperable from malfunctions, and the unit on GOES-13 was damaged by a solar flare in 2006. Payload: the main mission is carried out by the primary payload instruments, the imager and the sounder. The imager is a multi-channel instrument that senses infrared radiant energy and visible reflected solar energy from the Earth's surface and atmosphere. The sounder provides data for vertical atmospheric temperature and moisture profiles, surface and cloud top temperature, and ozone distribution. Other instruments on board the spacecraft are the ground-based meteorological platform data collection and relay, and the Space Environment Monitor. The latter consists of a magnetometer, an X-ray sensor, a high-energy proton and alpha detector, and an energetic particle sensor, all used for in-situ surveying of the near-Earth space environment. Satellites numbered 12 and greater also carry a solar X-ray imager used for two-dimensional imaging of the Sun. The GOES 13-15 series also have a sun-pointed extreme ultraviolet sensor. In addition, the GOES satellites carry a search and rescue repeater that collect data from emergency position indicating radio beacon and emergency locator transmitter beacons, which are used for search and rescue purposes by the U.S. Air Force Rescue Coordination Center. Satellite designations. Before being launched, GOES satellites are designated by letters. Once a GOES satellite is launched successfully, it is redesignated with a number. So, GOES-A to GOES-F became GOES-1 to GOES-6. Because GOES-G was a launch failure, it never received a number. Since then, GOES-H to GOES-P became GOES-7 to GOES-15. The procurement, design and manufacturing of GOES is overseen by NASA, while all operations of the satellites once in orbit are done by NOAA. GOES spacecraft have been manufactured by Boeing and Space Systems Loral. The two current GOES series are documented in the GOES-E-Euro-M databook, and GOES-N series databook. The future GOES series is being built by Lockheed Martin. GOES-13 was launched by a Delta IV rocket from Space Launch Complex 37B at Cape Canaveral Air Force Station in Florida at 22:11 Greenwich Mean Time, May 24, 2006. The launch of GOES-O was delayed several times due to various issues. GOES-O was launched Saturday, June 27, 2009 at 6:51 p.m. EDT from Florida's Cape Canaveral Air Force Station at Space Launch Complex 37, piggybacking on a Delta IV rocket. The GOES-O satellite is a part of the GOES-N series, and was renamed as GOES-14 once it successfully arrived on orbit. GOES-14 is in on-orbit storage, and will be able to be activated for duty if another GOES satellite is decommissioned. GOES-P launched successfully on March 4, 2010 at 18:57 Eastern Standard Time. Boeing would have built and launched a GOES-Q only if either GOES-O or GOES-P failed to be delivered on orbit in good working order. In October 2006, NOAA repositioned GOES-10 over the Amazon region, to provide full-time coverage for South American countries. Although NOAA currently sends images to South America, the frequency drops from 30 minutes to 3 hours whenever a storm occurs in North America, which is roughly 40% of the time during the hurricane season. In 2010, NOAA assigned GOES-12 to observing South America, although it has expended its fuel and several science systems have failed. Future: the GOES-R series of spacecraft is in the development phase. The first GOES-R series satellite is scheduled for launch in early 2016 and is expected to remain operational through December 2036. The proposed instrument package for the series initially included the Advanced Baseline Imager, the Hyperspectral Environmental Suite, the Space Environment In Situ Suite, which includes 2 magnetospheric particles sensors, an energetic heavy ion sensor, and a solar and galactic proton sensor. The Solar Imaging Suite, which includes the Solar Ultraviolet Imager, the Solar X-ray Sensor, and the Extreme Ultraviolet Sensor. The Geostationary Lightning Mapper. And the Magnetometer. In September 2006 the Hyperspectral Environmental Suite was cancelled and the planned number of satellites was reduced from 4 to 2 by NOAA due to concerns about cost overruns. The planned delivery schedule was also slowed down in order to reduce costs. The expected cost is $7.69 billion, a $670 million increase from the prior $7 billion estimate. The contract for constructing the satellites themselves, as well as the magnetometer system, SUVI and GLM, was awarded to Lockheed Martin. The award was challenged by Boeing, who lost the bid. However, the protest was subsequently dismissed. The ABI will be delivered by ITT Exelis. The SEISS will be delivered by Assurance Technology Corporation. XRS and EUVS will be combined into the extreme ultraviolet and X-ray irradiance sensors, which will be delivered by the Laboratory for Atmospheric and Space Physics of the University of Colorado. The contract for the ground system was awarded to a team led by the Weather Systems Division of Harris Corporation, including subcontracts to Boeing, Atmospheric and Environmental Research, Honeywell, Carr Astronautics, WAL Laboratories, and Ares. History and status of GEOS satellites. GEOS-1, launched on October 16, 1975, decommissioned. GEOS-2, launched on June 16, 1977, decommissioned. GEOS-3, launched on June 16, 1978, used as a communications relay for the South Pole Research Station. GEOS-4, launched on September 9, 1980, decommissioned. GEOS-5, launched on May 22, 1981, deactivated on July 18, 1990. GEOS-6, launched on April 28, 1983, decommissioned. GEOS-G, launched on May 3, 1986, failed to orbit. GEOS-7, launched on February 26, 1987, used as a communications satellite by PeaceSat. GEOS-8, launched on April 13, 1994, decommissioned. GEOS-9, launched on May 23, 1995, decommissioned on June 15, 2007. GEOS-10, launched on April 25, 1997, decommissioned on December 2, 2009. GEOS-11, launched on May 3, 2000, decommissioned on December 16, 2011. GEOS-12, launched on July 23, 2001, providing coverage for South America. GEOS-13, launched on May 24, 2006, in operation as GEOS East, returned to operations October 18, 2012 after an anomaly. GEOS-14, launched on June 27, 2009, standby spacecraft, located at 90 degrees W as of December 2012. GEOS-15, launched on March 4, 2010, in operation as GEOS West starting December 14, 2011. GEOS-R, scheduled for launch in 2016. GEOS-S, scheduled for launch in 2017. GEOS-T, scheduled for launch in 2019. GEOS-U, scheduled for launch in 2025. See also, Applications Technology Satellites, 6 early geosynchronous satellites that carried communications, meteorology and navigation payloads, Emergency Position Indicating Radio Beacon, MTSAT, Japanese Weather Satellite Program, Polar Operational Environmental Satellites, Remote Sensing. Further reading, Lombardy, Michael A. Hansen, D. Wayne. The GEOS Time Code Service, 1974–2004, a retrospective. Journal of Research of the National Institutes of Standards and Technology 110, 79 €96 doi, 10.6028/JRES. 110.008. References. This article incorporates public domain material from websites or documents of the National Aeronautics and Space Administration. External links, National Weather Service satellite images, GEOS operations on NOAA website, GEOS-R article, LMIBM partnership announced for GEOS, GEOS Gallery, GEOS Weather Satellite Viewer Online, GEOS East and GEOS West Weather Satellite Viewer with 2 months of archived data. Social and economic benefits of GEOS from NOAA Socioeconomics website initiative, Introduction to Satellite Imagery, Spherical Panorama of GEOS-O in the Cleanroom.